Okay, so let's get started. So welcome, thank you all for participating in this video where I'm going to go through one of the models that we've been working on for a vaccination clinic. So before we get started, I'm going to ask you guys to spend 10 or 15 seconds introducing yourself. Why don't we start with Brianna?
Hi, I'm Brianna Swan, and I'm a PhD student at NC State and hopefully finishing up in the next few months.
Thanks. How about Joe next?
Hi, everybody. I'm Joseph Agora. I'm an assistant professor at Oregon State University in industrial engineering.
And finally, Katie.
Hi, I'm Katie Smith, and I'm a management engineer at Emory Healthcare.
Okay, thanks, guys. So just sort of an introduction of what I'm going to do today. First of all, there's a caveat. I don't know really anything about vaccination clinics, and I don't know anything about healthcare clinics in general. So my interest here is in the simulation modeling and the actual analysis side, so that how to use simulation to solve this problem. So the sum total of what I know about vaccination clinics and pretty much healthcare in general is from a conversation that I've had with Katie based on her model at Emory and with our local, some people from our local health department who were asking us to provide some assistance for what for us will be a large scale vaccination clinic that they're setting up in the Auburn-Opelika area. And then finally, I had a couple conversations with a licensed pharmacist, friend of mine, to just sort of ask some questions about vaccination. So that is the sum total of my knowledge, which is over maybe 3 or 4 hours of work. And so my goal on the video was really not to, or for the model that I'm developing now, is really not to develop a specific clinic model, but to develop a combination of a template and some modeling methodologies that users could apply to simplify their implementation. And so what I was particularly targeting is users who either know Simio or are willing to learn Simio, but might not be power users or might not be sophisticated users. You might have taken an undergraduate class or taken an initial training thing, like an online training course or something like that. And then I'm going to go through some of the things that are that novice users typically don't use. And so the two components that are outside of what is typical with Simio that I'm gonna focus on in my model is the use of custom objects and the use of data generated modeling. And so my goal for today's session is really to stay at a really high level. So I'm not going to do a deep dive into all of the Simio stuff. I'm going to demonstrate some of it, but I really kind of want to stay at a high level. And then if it's warranted or necessary or people want it, I can do a follow-up video that goes as detailed as someone wants to get. So having said that, anyone want to make a comment, question before we jump in? Okay, well, if you have questions along the way, this is going to be interesting having an audience for this. So just unmute and jump in with questions and interrupt as you see fit. All right, so I'm going to share my screen and turn off my video here. Okay, so you guys should be able to see my screen. You see my Simio screen?
Yep.
Okay, so this is the sample model that I developed. It's kind of a combination of a model and a template. So let me just run it so you can see what's going on while I'm talking about the details. So I'll just really start a camera sequence while I talk a little bit about it. So you can see I have patients arriving and they go through 2 different process flows. Either they're regular patients or they're high-risk patients. And if they're a regular patient, they go check in. And then they go to one of what I have here is 5 inoculation stations. If they're a high-risk patient, then they first go to the high-risk consult. Once they finish at the inoculation station, they either go to the observation area or the high-risk observation area. And the observation area, they're supposed to stay, as my understanding, 15 minutes after they receive the shot. And if they're high risk, or by some other metric, I really didn't understand the difference between the high risk in observation and the high risk in HR consultation. So it's one of the things I'm going to have to get from our stakeholder. But in this model, if you're just randomly selected as a high risk patient when you arrive, and if you are such a high risk patient, then you're going to go through HR consult, and then you're going to go to the high risk observation area. And so you can see the model. I have 3D model, 3D animation here, pretty simplified 3D animation. I use animated people and things like that to try to make it look a little bit more realistic. I have a really simplified experiment here. And so one of the things that I really don't know much about is what do people want to know? You know, I understand that people want to optimize design, but it's really not clear to me what performance metrics are of interest. So I just put some really simple ones. The performance metrics that I have are the number of patients that you see in a day, the maximum number of people that are in the observation area. That was of critical interest to our stakeholders, was do they have enough space in that observation area where people had to wait for either 15 or 30 minutes. The closing time, because I have an arrival process that has batches of patients arrive on a periodic basis. I think in my model, which I will show you in just a second, I think it's about every 15 minutes you have a batch of patients. So it would be analogous to having scheduled arrivals during a time window. I think that's pretty common in this area. And so at the end of the last arrival window, there's some uncertainty about when the last patient will be done. So I monitor the closing time. So that will be the time that the last patient leaves the observation area. And then I track also the average number of patients in the observation area.
Do you have like a cutoff time for when you stop patients from coming in?
Well, so I use an arrival process where it's based on time windows. So I'll just jump and show you that right now. Is I have a patient arrival table. And so the way I have this particular model set up is every 15 minutes, I have either 32 or 33, looks like, yeah, 32 or 33 people arrive. And I'm going to show you how I arrived at that number in just a second. So I can control that. And so this would be, you have 33 slots every 15-minute window. And when people sign up for that, once a slot's full, then, it's full. And so the model terminates when this last person in the last slot leaves. Okay.
Sorry, go ahead.
Sorry, I will say, and this is less of a simulation question and more a comment and more of a stakeholder or analysis comment. But from our perspective, a very important metric is either the average number of people in the clinic at a time and or the maximum number, due to both from the perspective of it being a pandemic and that we want to limit the amount of people in a space, and also fire codes. And so that is something that has been particularly relevant to us. So I just wanted to make that comment, since you said you weren't sure what metrics.
Yeah, that's good. I can add that easily, because the way I've modeled this, I have one instance for patients. And so whether you're high risk or whether you're a regular patient, you're still an instance of that same object class. And so I can do statistics on the overall patient. So what you said about the average number, maximum number, any kind of percentile number that you want. And then we can also, as I showed here, I showed the number in the observation area, but I can also track individually the number that are at various queues within the system.
Yeah.
Also
Joe,
I had a comment as well. So I'm working with Oregon Health Authority, and I guess not individual vaccination clinics, but a little bit more wide across all the county through facility location. And something that Oregon Health Authority specifically is very interested in is equity and distribution. So an output I think that they would, that maybe stakeholders would like to see is the attributes of the patient, like what types of patient populations on average are getting. Is it more the elderly that's getting it? Is it a particular demographic? I know that's something that OHA specifically has stressed to us, like in multiple meetings. So is that capable here to attach these attributes to these patients? I'm a strain. Yeah.
You could, yeah. So if you wanted to modify the input data so that you had, the characteristics of people, you could certainly show it on the screen. So I could, when I run the model, for example, let me just get it going and pause it. I could attach to each one of these people some characteristics like that. As to what the results are, I mean, that's pretty much going to be a function of the input. So you would have to tell it. If you want to say how many people are over 65 or how many people are over 75, I mean, that's going to be an input to the model, not an output from the model, because someone is making that decision externally to the model. But demonstrating it would be really easy to do. And so if the stakeholder wants to see, that's one of those things from a simulation perspective, that while the simulation might not be deciding that for you, it's displaying information. So it's important to the stakeholders, and it also tends to lend credibility to the modeling effort.
Right, right. And I think those types of patient attributes also determine, to my understanding, where you go, what observation
Oh,
do
okay.
you, at least that's, we've met with our College of Pharmacy, like
Okay.
and he says this, he's been to one of our physical like mass vaccination sites,
Mhm.
and it's your risk is assessed based off of your attributes of
Okay, well, that's a totally different scenario then, because if the flow that you would do is dependent on any kind of attribute then, other than high risk, then you would want to incorporate that into the model. Like if I reserved particular inoculation module for elderly or otherwise infirmed or something like that, then you would incorporate that into the model logic, which you could easily do. And then you would look at then it might be interesting to look at performance metrics like who spent longer in the system. Was it, do we have equity across all of the different customer patient types, because they're doing separate processes, they're doing individual processes. So yeah, that would be really interesting and fairly straightforward to do, to incorporate into the model that we have here.
Okay.
Okay, so that's the basic model. And so, as I said, there are two things that I really kind of wanted to talk about and show you guys today: the use of custom objects, and then the use of data generated technology. And so I have in my model, the custom objects. I have an inoculation module, I have a patient arrival source, I have a clinic server, and a patient sink. And so you can see here 5 instances of my inoculation module. And then each one of these, the check-in, HR consult, and the observation are both instances, or all 4 instances of the clinic server. And so you can see, if I look at the individual objects, these are very simplistic objects. So there's nothing currently sophisticated going on with these objects. So just the inoculation module, for example, I basically just made it look like a table. So I modified the external view, changed the queue around to make it a discrete queue, and things like that. And then I set some table references. So with all of the custom objects, the data, in the case of the inoculation server, so let me jump back to the model and just say, if I pick one of my inoculation servers, you can see the 2 pieces of data that are of primary interest are the capacity. And for my simple model, they all have capacity too, but that's all settable by the user. And the process time, which again is also settable by the user. And so you'll note that these are referencing back to the table. So if I look at my data tables and look at the resource table, the resource table defines all of the object instances in my model. And so here are my 4 inoculation servers modules, and you can see that I have the time, and then I have that capacity of 2. So all of that is incorporated into the custom object. But that's really it. There's no detailed behavior going on in there. I'm not modeling the actual injection or any of the administrative work that goes on. But the key about using a custom object is that I could, even after the model's built, go in and modify the behavior of the individual objects accordingly. So if that became an important aspect that you wanted to incorporate, you wouldn't have to rebuild the model, or you wouldn't have to look at updating all of the inoculations servers manually, because you would be updating the custom object. And so my clinic server, again, same kind of thing. It just has the table references, and then I modified the external view so that it, let me see here, so that it looks like a table. And then again, change the queue, and then change the input and output node. So nothing major going on here. It also just has the table references. One other thing that I meant to mention in the inoculation server is I also set the buffer capacities, the input and output buffer capacities, to 0, so that you can control where patients wait. So if you don't have capacity at any one of these, I don't want to send patients to wait there. I want to hold them back near the check-in area so that they can be distributed equitably. So that is also built in to the custom object. Okay, does that make sense? Custom objects?
Yeah. One thought that came up was that utilization may be important output metric too.
Mhm.
Maybe if they don't know if 33 spots is good every 15 minutes or something like that, then the utilization might be helpful because that's like the nurse, I would assume. I guess I'm not sure who's giving the vaccine.
Yeah, we have capability to get all of the resource utilizations and all of the space utilizations individually. So all of that is tracked just like it is in, when you use Simio normally. So the fact that I'm using a custom object doesn't change that at all. If I wanted to, I could make custom statistics within the custom object. Again, in my inoculation module is really simple in that I don't model having an assistant or a scribe or something like that. I just say what's the capacity and what's the time. And so I don't go into the detail about what's actually going on there. If you did want to do that, you could with the custom object, and then you could incorporate specific types of statistics that you would want to track based on how that on how the module worked.
Do you think that that could be used at the end then to sort of like optimize the number of spots they have available for patients?
Oh yeah, absolutely. I think that the use case here is a couple of use cases. One is to decide how to allocate staff. If you have a fixed number of people, do I have more people at check-in, or do I have more people at HR consult, or do I have more people scribing, or do I have more people, at the observation? So where do you allocate people? I think is going to be one of the primary uses for this type of model. Also, as Katie said, space allocation. So if you have to keep the 6 feet and you have to make sure that you manage that process, the model would be able to tell you all of that when you violate that, or when people get blocked and things like that. Okay.
Okay.
All right, so how this works. So again, another basic component that we use that's pretty common Simio terminology is we use sequences. So how people move around within the system, how the patients move around is dictated by 2 sequences. I have a patient sequence, and here's where I define check-in. This is the inoculation, which I'll show you that in just a second. And then they go to observation, and then they leave. And if you're a high-risk patient, then you have this high-risk consult interjected in there, and you also go to the high-risk observation. So notice I don't have any links here. I don't have any paths. So the entities are all moving through free space, and all of that. The destination is controlled by those sequences. So when a patient arrives, I have a really simple process that says, is this person high risk? And if they are, then I set their symbol to red. So when you run the model, anyone with the symbol number 6 would show up as red, is high risk. And then I set the row reference to assign that sequence. So this is the high risk patient sequence. Otherwise, I pick a random color, a random symbol, so that, I get a mix of people. And then I set the row reference to the patient sequence. So these set row steps are what actually tie the patient entities to the corresponding data tables. Okay, that makes sense?
Yep.
Okay, so now I'm gonna show you this. I want to talk about this notion of data generated. And so to do that, I'm going to switch models real quick because I don't want to mess this one up. So I'm going to switch. You can see up here I have a temporary model because I'm going to do some manipulation of this model, and I don't want to mess up the model that I have. Okay, and so one thing that I haven't shown yet is I have an Excel file that stores all of the information for me. So I have like the resource table that you saw, here it is. My patient arrival table, which I showed you, here it is. I also have a path table, which I'm going to show here how to use that in just a second. So these are all of the tables that I have in the Simio model, but I do them in Excel because I find Excel a little bit easier to work with when you're doing table manipulation. For this particular model, I'm not binding the tables to the Simio model. I'm just pasting it in, as I'm going to show you in just a second. I also have a simulation page where I do some manual calculations. So you input anything in yellow is an input for you. So for this run, I said, okay, we're going to run 8 hours a day. I have a target rate of 1,000. That means my hourly rate needs to be 125. I put in the no-show probability. That should be yellow, 0.05. So this tells me how many patients I need to invite per hour in order to achieve my 125, given that no-show probability. And then I mentioned that I'm using time blocks where I'm inviting people. You would be equivalent of scheduling. So I schedule you in a particular time window. So I let the user specify what those block lengths are going to be. and my block lengths are 15 minutes. And so that for an 8-hour day, that means I have 32 blocks, and the block arrival rate needs to be 32.89 on average. And that's where, when we did the patient arrival process, that you saw that I had an alternating, or a random probability between 32 and 33. And so by having 10% 32s and 90% 33s, I achieved that block arrival rate of 32.9, which is what I need. I have inoculation modules. In mine, I have 10, because my modules, even though I only have 5 modules, each one has a capacity of 2. And I can specify the inoculation time, and then it gives me my inoculation, my kind of raw inoculation capacity. And then I have the same thing for check-in stations. How many do I have, and can I support? So just kind of like static analysis to convince myself that, without considering variability in any way, I have the raw capacity to do what I want. So that's the starting point that we have. Okay, so as I said, when I go to the resources table, if I were to go to my resource table here, my resource table, this table uses something called auto creation. So if I look at the column, the left column, the resource name, you can see that I have this property called auto create instance for the default instantiation. And so that means when I enter a row in this table, it creates a corresponding object. Okay, so if you look at my model here and I pick one of these, I don't really have any control over this. So I can't delete it or anything, because it's tied to that table. But if I go to the table, for example, and just say, okay, delete that, delete all the rows in the table, and then go back to my model, now all my objects are gone, because it's tied directly to that table. So you can see that I just deleted all of my instances, and I have a couple little errors here. And the errors that I have are because I have my task sequence, I have my entity sequences. So since I deleted these objects, these things no longer exist. So it's telling me that. And then one other thing that I have that I'll show in just a second is I have a list where I need to enumerate all of my inoculation stations so that I can use the selection process to decide which inoculation station a person goes to. So it's saying, hey, these things don't exist anymore. That's an error. But the idea here, and the beautiful part about this, and this is, as you will see, why I want to use Excel, is I can just grab all of these, so I can just copy these to the clipboard, and then if I go back to my table and then paste them in. Oh man, did I use the wrong? Oh, I did path. Sorry about that. Wrong table. Resources, and then paste it in. Okay, now all my errors went away. And if I go back to my model, you can see, okay, all of my objects are back. Okay? Because by entering an entry in the table, it creates the corresponding object. You'll also note that the layout is the same as I had. Well, that layout is controlled by the X and Z location for the object. So I can control it. If I have a physical layout, I could set this up and have the approximate locations in advance and then just construct the model. And it's a two-way thing. So if I go, if I go let's look at inoculation station 4, it's at minus 2115. If I move it, if I go over here and say, let's move it over here, it then updates in the data file. So when you get it laid out the way you want it, you can just copy this back into Excel, and now you have a way that you can quickly and easily regenerate the model in situations where you might want to do that. So if I want to say add another inoculation station, or I want to modify the look of the inoculation station, there are situations where I'm going to want to delete them all and put them all back. The other thing to note, yeah, go ahead.
If you were to create a new inoculation station right now and paste it into the facility window, it would create a new row in that data file.
No. So if I were to go in here and say, okay, let's add an inoculation module, right? It lets me do it, and it's in no way tied to the table. Okay. But in this type of, the reason that we have this auto-generated technology, you don't really want to do that. What you want to do instead is you just want to go add it to the table. So if I were to add it to the table, it would then create one. Okay, so you want to have that two-way relationship between the data and the object engines, but you can still have them, because as I showed, if I delete these, if I just delete everything here like I did before, even in my base model, I have a couple of things that are still there. I have my my distribution, which is a transfer node, and then I have my patient model entity, because it again is tied to the table, and it has the animation and things like that. So these two are hard coded. And it's just these objects that are that are auto-generated.
So how did you start? Did you like create the objects first and tie it to the table, or?
Yeah, so I
Like-
created the object instant. I created the object definitions, and then if I create one, so I have this nice layout here. As I said, if I just were to create one, okay. Well, one of the things I was going to show you that I will go ahead and do, and hopefully that'll answer that, is I know from looking at Katie's Emory model that they have more processes. So they have where do you check? Is this the grid system, Katie? Is that what it is?
Yeah, the grid system is the state system that we have in order to check to make sure that I think that the patient is eligible, that they haven't received vaccines in the past 2 weeks, and then where we log that they received their vaccine. So this is information with the state.
Yeah, so let's
yes,
say
it's
that I
called
wanted to
grids.
incorporate that process into my model. The first thing I would do is I would go put it here. So I'm going to do grits. We have grits in Alabama too, by the way. And I mean the food, I don't mean the... Okay, so I'm going to say, okay, make this a clinic server. I'll just leave the location at 00, and then I can put the time. I have no idea what the time is, so I'll just use the same thing that we did for the inoculation module, and I can decide how many people are working at that. So I'll just put 3 here. And so when I go back to my model, you can see here it is. It created that instance, and it put it here at 00 because I didn't specify the location. So then I would go back, and if I wanted to incorporate that, I would say, where does this go? And so we just kind of move this guy up and say, well, let's go here first, right? So I'm moving some things around. And again, remember, when I'm moving these things around, it's continually updating those locations in the table. So once I get the layout the way I want it, I'm going to cut all this out or copy all of this back into Excel. So I have all of those locations. So I now have my grid station, and then I can go into my patient sequence and say, okay, where do we want this? Let's make it before check-in. I'm just going to insert a row and make this input at grits. And then in my high-risk patient, same thing. So insert a row and put it grits. And so now when patients arrive, instead of going to check-in first, they're just going to go to grits, and it doesn't matter where I put it. So if I move it over here, they're going to go there, right? Because it's being controlled by the sequence rather than by any type of arc. So when they come out of here, I guess I had the processing time quite large. So when they come out, they're going to go to check-in. So there's the first one at check-in. So adding new processes is pretty simple. Rather than dragging it from here, rather than dragging it from the standard library and placing it, I'm going to put it in the table, set the corresponding characteristics. And the goal here of this type of modeling is that I don't want to edit any of the objects instances by hand unless I absolutely have to. Okay, because I want to put everything in the custom object. And so one of the things that you'll note that supports this type of routing by sequence is if I look at the transfer node out of the object, the entity destination has to be set by sequence. If I use a regular server, then I have to manually set that. But if I use my custom object, I can make that the default. And so it makes updating the model easier. And if you have someone who, as I said, is not an expert at modeling, it makes their life much easier to have that kind of thing built in.
Okay, this
so
is super cool.
Does that answer your question about how to create the entities?
Yeah.
How to create the object instances?
So to get the process right, so you would create the custom objects first and then put them into the table, which would then like auto create them in this visualization.
That's right.
Okay, cool.
And so when I start a model like this, the first thing I do is, I would just go right click and say, okay, let's subclass, let's create a new object. So there's a new object called my server. Okay. And now that I've created, I haven't made any changes to it. So the my server object is going to be exactly like a server, but then I could go into my data and say, well, let's add one of those. My server 1, call it MS1. And now it's available here to add. We'll just add it at 00. And there it is, MS1.
Okay.
Okay, so it just adds it there. Now, if I want to then, because I only copied the server or subclass of server, if I want to change its behavior in any way, I can just go in the already created object and change its behavior. And then all of the instances in my model will inherit that new behavior. right? So when I do it again, I typically start out with a relatively simple one. I just say subclass of server here, subclass of server here. And then as I build more logic into the model, I do things like customize the animation and things like that. And so one more thing that I said that I was going to demonstrate here is I have paths. So if I want to automatically put a path in, let's say PO1, and I can either do path or I can do time path or connector. And let's say I want this to be, I don't know, output at HR observation to input at depart leave. What is patient depart or something? What do I call it? Patient arrivals. Where's departure? There's patient depart. How do they leave? Oh, patient depart. That's input though. I want output at patient departures. Yeah, I'm going to be cutting this out of the video, by the way.
Isn't patient departures a sync? So you would want input.
Oh yeah, thanks, Katie. That's right. I want to go to the input. Input at patient departures, right? And so now I've just added that row to the link table. And again, if I look at the name, I have that set to auto create. Go back to my model, and there's the path automatically created. So if for whatever reason you don't want to use sequences in some parts of the model, you want to use paths and link weights and all of that kind of stuff, it also supports that the automatic modeling, and so you can go in and make any kind of changes that you want.
And so could you also like add table columns for things like to make the logical or drawn to scale false and then change the length and stuff like that if you didn't have like a to scale model or whatever in your head?
Well, I mean, so how you do it is, so again, go back to the resource table, and I have these two columns. I have something called time expression 1 and integer value 1. And so those are tied to the capacity and the processing time. And so that's how, when I have any one of my inoculation modules, I can have different processing times and different capacities, and they will pick up the right one because they have that row reference.
Yeah.
So it works the exact same way with the paths, in that I can have, if I want to have link weights or something like that, I could have those characteristics of the object instance in the table, and it would read it from the correct row because I have this auto set row reference set to true, and I use it for auto create. Okay.
Yeah, and this is, I guess, I don't know if this is important, more just curious. Is this a style of model building that you use a lot? Because I've done custom objects a few times, but I tend not to really model in that way. And I'm just curious if this is something that you use a lot.
I pretty much always do it, because if you start out with servers, for example, let's just pick the easiest one. If you start out with servers, as you add complexity to the model, you're going to want to sometimes change the behavior of the server. Well, a lot of times I have multiple servers that I want to behave in the same way. Like in this case, if I want to say, let's look at adding an inoculation station, let's look at adding 8 inoculation stations or something, I want them all to behave the same way. So I have a couple of choices. I could just put a new server down and then update each one individually. I could copy one, right? But using a custom object just makes it a lot easier. The other thing that it supports is, let's say, so you can see in mine, all of my inoculation stations, for example, have the, where is it here? Here it is, capacity 2, okay? So I could go in here and say, hey, let's make this guy with capacity 4. So I could go in and say, let's make all of our inoculations capacities 4. I could just go in and do this here. So I go, change this to 4, 4, 4, 4, 4. Okay, and now they're 4. But when I run my model, see, I don't know if I've messed anything up by doing this, but when I run my model, what you're going to see is they have capacity 4, but you don't see it because I have the queue custom set up to support capacity 2. So if I knew that I was going to use capacity 4, what are my options? Well, I could go into each individual one. So I could go into this one, for example, and say, okay, let's pull this guy out. Let's pull this queue out. If I can grab it, let's pull this queue out. Let's add a vertex, and let's then add another vertex, right? So now I have 4, and I could configure them however I want, right? And so now this guy is going to show 4. But then for these other ones, if they're 4 also, I would then have to modify the queue accordingly. The alternative is to say, hey, I'm going to use 4 most of the time, so I'm just going to go in my inoculation module, and in my inoculation module itself, I'm going to do that same modification. Okay, and so now the modification, whether it's to a Q or whether it's to, you know, the color of the table or whatever else you've changed with respect to the animation, will be picked up by all of them.
Yeah.
Right, and so I could change it to 4, and they would automatically be picked up by all of them when you place those or when you recreate those.
Yeah, this would have been helpful for my emergency department simulation with all the beds.
Yeah,
And I'll perform the same way.
I mean, it's really a powerful technique. I mean, using this auto generation is really kind of it really is a powerful technique.
Mhm.
So I wanted to make sure and demonstrate that. And then the last thing that I kind of had in mind, let me get back to my model that's not my temp model with all my changes, is, you know, depending on what kind of Simio license you have, if you have access to the planning tab, you know, you can use Gantt charts and things like that. So when I do a resource plan or create a plan, what it does is it creates a deterministic version. And now you can see over time exactly what happens. So you're interested in what's happening at check-in. Well, here's all the patients that went to check-in in every block of time. You want to see who is in observation? Well, here they all are. So here's a particular patient, here's a particular patient, here's a particular patient. You can see exactly when they entered, when they left. You can see what the gaps were, where you had capacity remaining that you didn't use for inoculation and everything else. And so if you expand this, you can actually see the task. So if I were to use tasks where I say, okay, Q&A, swab the person, give the person the shot, you know, sign the paperwork, whatever, I could break all of that down and you could actually see exactly what's going on within your model. And so the ability to see this really kind of depends on your license type. If you have either professional license or an RPS license, that technology is there. And so that can be, you know, a really useful function. And so, as I said in the beginning, the idea of my model here was not to create the end-all be-all vaccine clinic, but to build some technology that people could use to do that. And so if you think about, there's some really nice enhancements you could easily make here. An easy one is you could just do better animation. Oh, well, before I go on, that's one thing that I actually forgot to say is if you look, go back to my temp model here. That's my actual one. Yeah, if I go back to my temp model, let me just see if I can see both of these here. You'll note a couple of things. Inoculation station 5 here is at a different orientation because when I auto placed it, it places the object in its orientation that's defined by the object. Similarly, when I look at my cues for my observation and HR observation, those are both the standard cue defined by the object. But in my model, those are different because I manipulated those. So I physically, or I went into this particular instance and rotated it. And I went into these 2 particular instances and moved those. And the thing that you'll find sometimes to be shocked by this is when you then go back in and auto generate, you lose all that because you can't auto generate some of the animation aspects. So if I were to go in here and like I did in my temp model, now you see why I use the temp model. If I was to delete everything out of the resources table and then paste it back in, it would all come back in and the model would work perfectly, but I would lose these custom animation characteristics, like this one being oriented a different way and these cues being different and these status labels that tell me what's going on. Those all have to be done manually. So sorry about that, I forgot to say that. And so better animation, you could obviously improve the animation. You can see in my model, I don't really have the healthcare workers at all. You know, I just have the patients coming in, but I could put the healthcare workers here if I wanted to. I could have walls, I could have more, you know, better animation if that's something that you need to do, either to, you know, sell to your stakeholders or whatever. That's something you do. You could do, as I've said several times, more detail in any of the modules, whether it's the inoculation module, so you include the doctors or nurses or pharmacists or whoever's doing the work, or the check-in process where you would say, okay, well, you know, I need to probabilistically, I don't know, have someone take a longer time or a shorter time or something like that. So just more detail in the modules you could do. You could do inventory replenishment. So if you have a pharmacy counter or something, so how do the shots get to the inoculation modules? You could use Simio's inventory elements and use inventory replenishment and model model that whole pharmacy side, that would all be pretty straightforward. You could model parking and patient moving in and out of the clinic. My understanding is that with our clinic that's opening this week, you have to wait in your car for a period of time. So all of that could be easily incorporated in. You could have non-stationary patient arrival. So instead of having all of the hours of the day look the same, I could have, I don't know, more people coming at lunch or before work or after work or something. So all of those things, I think someone who has domain knowledge could take the template of the model that we built here and incorporate all of those features, and then the performance metrics that we talked about also, and really make a really nice model. It gives them a leg up on getting things, getting started with the model and making it flexible to different changes and how the model, again, if you think about a situation where I have Monday through Friday, I have 5 modules, and Saturday and Sunday I have 12 or something like that. It's really simple to make those kinds of adjustments if you do the modeling this way.
Yeah. I will say, I don't know what your goal is long term. I do think for us, and what I have observed, since I would have to guess that most of these vaccination sites are handling the vials and turning them into doses on site because of the short expiration time. That is a really important aspect that I think could really help. Personally, what we've seen is with no-show rates and stuff, we can get the majority of our doses done by midday, but then people have to stick around so that we don't waste any at the end of the day and things like that. And so I think there is a lot of opportunity there. That's just my 2 cents.
Yeah, our clinic supposedly has that too. So the clinic that they're opening has is going to have the pharmacology part, on site too. I don't know anything about it, how it works and all that, but I think that would be a really awesome enhancement. So sort of expanding on that, back to your original question of, you don't know what the goal is. So I'm going to post all this on my website here. I'll show you, this isn't public yet, but it will be after I get off this call, my vaccine clinic model. So I'm going to place this description of the modeling template. And right here, you can see where you guys are going to be. It says we're making a Zoom recording. So this paragraph goes away, and the video that I'm making right now goes right here. And then I say to people here, it doesn't have any of the metrics, make enhancements. Here's all the files that you need to do everything I showed. And then, by the way, if you find the model useful, leave me a comment. If you use the model, leave me a comment. If you want to contribute by, say, maybe you add a pharmacology model or some module or something, then contribute that. And, I'd like to make sure that I can get that out there. And so whether you email me and I link to your website, or you send to me, or you and I work together, whatever situation, that's the goal that I'd like to have. Is I'd like to be able to get people who have the domain knowledge to be able to use the Simio modeling technology to create meaningful, useful models, and then maybe post those, or at least talk about success stories for doing that. And so that's what I'm setting up here to support that.
That looks great. I hope that it gets widely used.
Well, we'll see. One of the things that, let's see, I'm going to stop sharing my screen now. I'm done showing stuff, unless you guys come and ask me questions, so I can go back to video and say, I hope, my goal is for it to be widely used. And as soon as I get this up, I plan on publicizing it. I don't have a lot of followers or anything like that, but the ones I do have occasionally will repost and get people interested. And I do have a handful of people that I know who work in healthcare that I'm going to send this to and say, hey, check this out, give it to your student or whatever, and then and take a look. So that's my overall goal.
Yeah, well, if you do much more, Joe and I might be having you as an invited talk at Winter Sim in the COVID track. So just be aware.
I need to pair with someone who has the domain knowledge.
Yeah.
Again, because I can talk about the modeling, I can talk in more detail about the modeling, but what we really need to have to make it interesting is someone to actually use it to make decisions in a real healthcare, a real vaccination clinic, or talk about how using the model for prediction or staffing or something improved their vaccination process. That's really what we need for talks and things like that. On the technology side, I'm happy to talk about the technology to anybody, but what we really need thinking about for, to get the vaccine rolling is we need some success stories.
Mhm.
Yeah,
So
this is extremely useful. They've been we have a OSU vaccination, Oregon State vaccination work group that has mostly like a pharmacist and
Mhm.
kind of those domain experts that are on the ground in the vaccination clinics, and they're trying to coordinate that. And they've, I guess, asked me as an IE to look at the specific. They started off with the vaccination clinics, like individual vaccination clinics, and
Yeah.
I think things were moving so quickly, and also I just don't have as much expertise in like the simulation kind of realm. So, and my colleague and I kind of moved towards those more facility location type of models, but they've asked for something very similar to this. They even recommended me to go to one of the vaccination clinics that were like an hour away.
Yeah.
It was during the week though, so I wasn't able to go there because he was like, yeah, if you can observe the process. He mentioned intake is like huge. Like it takes a long time, especially since we're going out to the communities now. When it was with hospitals, it was easy to say, oh, you have this, and but now that we have random people showing up, we don't. It takes like a lot longer to process them, and so I'm definitely going to be looking into this model, Jeff, because this is very interesting, and I think I might be reaching out to you. I'm not going to lie, and maybe some of our College of Pharmacy people might also be very interested in this model. So thank you.
That's what we want. And so, as I said, when I get done editing the video, I'm going to post it here so they will be able to watch it if they want. All of the files are here. So that's the link you need to, and again, I'll send that also. But the goal is for other people to use it and then hopefully reach back and provide information for other users. So we'll see. We'll see
And we
where it
might
goes.
be able to collaborate on the pharmacy component because I am hoping to do the analysis on our side, the staffing part this week, and move
Yeah.
on to adding the pharmacy component. And then since I do have, I'm not a pharmacist, but I have a pretty good amount of knowledge at this point. I've spent a lot of time at our vaccine clinics, so I might be able to help add that.
Yeah, that'd be
that
good. As I said, Simio has some really nice inventory features that let you have, inventory. So you think about having inventories of vaccine at each individual inoculation module. These are going to be in the syringe already, and then you're going to have inventories in the vials, and it will automatically, or it will let you control how that replenishment process works.
Yeah.
So okay, it's time to replenish when a certain event happens, or it's time to start working on the vials when the inventory on the floor gets to some target level. So all of that functionality can relatively easily be built in if we have someone with the domain knowledge. So Katie, that'd be awesome. I'm
And, like,
happy to help on the Simio side of how to
Yeah.
implement those kinds of things.
And on a personal level, I mean, it's a much more interesting modeling process, in my opinion. Like the clinic and people moving through it and whatever. I mean, I keep trying to stress this to people I've showed it to. I was like, this is a really simple model because
Yeah.
the process is very simple. And so, because, they're like, oh, we could use this in so many ways. And I agree. But I'm like, if you're going to, building an ED model is going to take so much more time because this model is simple. The process
Sure.
is simple. But the pharmacy component adds a good amount of complexity. And I think it makes it, from, just me liking simulation, more interesting.
Well, if you incorporate the stuff Joe brought up about having demographics, or you have patient-specific characteristics that change the process.
Yeah.
So, if you meet X criteria, you go here. If you meet Y criteria, you go here. But then making sure that it's equitable in terms of the time and the queues and all of that kind of stuff, I think that could add some interesting aspects also.
And we do kind of have that at ours because we have patients versus employees, and the way that we, in their charts or whatever, put in that information. We use two different systems, and it takes different amounts of time, and they have different consent steps. So we have that a little bit. Eventually, hopefully, we will be done vaccinating employees at like a big site. So, while we have it, it's hopefully going to go away. Granted, we'll always have new employees. So.
Well, as I said, I'm going to process the video and then put it up, and then I will let you guys all know. And so send this link to whoever you want to send it to. The more people who know about it, the better. Because I think if we get people out there, at least find out if it's useful to anybody.
Yeah.
I'm looking down at my time, and I think I told you guys half an hour. Once again, my ability to predict time when I do these kinds of things is not very good. Just from now on, if I ever ask you to do it again, just multiply whatever I tell you by 2.
Awesome.
Well, this was really interesting. So
yeah, super interesting.
Thanks to all of you.
I had one follow-up question actually.
Okay.
Jeff, if you is it are you able to incorporate like a mixed like agent-based kind of model within this? If you say were to model the customer experience or the and I guess it how it affects the future arrival rates maybe. For instance, if you have specific agents that have a worse off or longer like throughput times and they have to go through certain, and then that agent eventually exits the system and then impacts the revisit rate of or the arrival rate to that clinic. Is that possible, do you think?
Yeah, so the answer to the question of can we incorporate agent-based is really kind of yes and no. It
Okay.
really depends on what specifically you mean. So if you describe a scenario, you can say. So it doesn't implement true standard agent-based where you're looking for things like emergent behavior and you're looking for agent interaction that you don't code or that you don't explicitly specify, but it does what you were talking about. If you want to have different arrival streams or you want to have certain characteristics of the system impact the arrival stream, it does that kind of stuff is doable. So the bottom line is you have to be more specific about what you want that is agent based, and then I'm happy to say yes, it can do that, or it would be hard, or whatever.
Okay, sure. Yeah.
A lot of people mean a lot of different things when they talk about agent based.
Yeah, very true.
Yeah. Okay, guys. Again, thanks again for participating, and I will let you know when this is up. And if you have any other questions, let me know. Feel free to share it, as I said. And if you do get the model and want to experiment with it, don't hesitate to reach out to me.